Hi all, this is Pednankala Karthik Reddy and I am pursuing my Masters in Cardiff Metropolitan University. I have placed as data science intern in New IT Nest located in London. I am involved in NLP based project and gained more experience in this field. Welcome you all to the project presentation. The title of project is Interview Performance Evaluator, which is designed to meet the expectations of HR department to find the best candidate for the given job of any organization. We have done this project under the guidance of Mr. Sharat Chandra, Senior NLP Developer, and under the mentorship of Ms. Vaishali. The project is divided into 8 parts: project goals and objectives, business pipeline, technical stacks and architecture, data collection and extraction, data preparation, model building, model performance, deployment, output, and conclusion. The main idea behind the project is to maximize the automated evaluation process by reducing human intervention and also to minimize the manual selection cost and time of any organization. We do have certain constraints like automated criteria can hurt the diversity and good candidate may be thrown out of the race simply because they don't include certain keywords in their applications. This model is good for preliminary screening but not enough to make a final decision on hiring a particular candidate. So here we are using CRISP ML methodology. Firstly, business and data understanding. Here we go through the success criteria and go through the feasibility of application and data collection and data quality verification. Then we move to data preparation. Here we work on feature selection and then we will clean the data by using different modules of Python. Means we need to do text pre-processing and then we move to model building where we build a model by using different modules of Python. Then we move to testing and evaluation phase of model where we will check the performance of the model and robustness. Then next step is to deploy the model by using different web frameworks like Flask and PyWebIO. Finally, monitoring and maintenance where we will monitor the application and there is some upgrade needed, then we will go for the maintenance. Next thing we need to discuss is the technical aspects of the project. Here we are using Python programming for model building and deployment. We are using transformers which consists of encoders and decoders, and for model building we are using one of the form of BERT model. BERT is a transformer which has 12 encoders and decoders, 768 hidden layers, 348 million parameters and 12 attention heads. For data storage and collection we are using MongoDB database. For deployment we are using PyWebIO and Flask. Both are Python frameworks which allows us to build web applications. Next we discuss about the product architecture. First we collect the data according to the client requirements and build a corpus. Then extract the corpus to Python from MongoDB database by using PyMongo library. In similar way, interview questions and applicant answers will be extracted from MongoDB database. After extraction, text pre-processing will be done on the corpus. Pre-processing steps such as tokenization, stemming, lemmatization, and stopover removals. Then next step is to perform the various embeddings such as token embeddings, interval segment embeddings, and positional embeddings. Token embeddings and interval segment embeddings used by BERT to find the start and end of the sentence. Position embeddings is to identify the position of each word. Then all these embeddings will go as an input for BOT model which have 12 encoders, 12 decoders, 12 attention heads, 768 hidden layers, 340 million parameters. So as an output it will generate a context vector. It will describe how words in corpus are related. In this way the corpus is trained. In interview questions, first we will extract the questions from the database, then text pre-processing, then interview questions will go as an input to the BOT model. CLS is defined as starting point of the sentence of interview questions. SCP acts as separator between questions and corpus. The question will be answered according to the specific keywords. The model answer will go as an input to the sentence transformer. The sentence transformer is mainly used to check the similarity score between model and applicant answers in a better way with more accuracy. Next step is to perform mean pooling to extract the keywords and then we'll perform cosine similarity. Before calculating the similarity score, check the answers provided by the applicant. For applicant answers, perform the same steps as done for the interview questions. After performing the previous steps, similarity scores will be calculated on model answer and applicant answer. If the score is greater than 40, the applicant is successfully cleared the interview, else the applicant has failed the interview. The threshold value 40 is not fixed and it depends on the client requirements. Finally, after successful model building, the next step is to deploy the model. Flask and PyWebIO are the two Python libraries were used for deployment. Next, data collection and extraction. For data collection, we are using MongoDB database. MongoDB is a document-oriented database which stores data in JSON-like documents with dynamic schema. It means you can store your records without worrying about the data structure such as the number of fields or type of fields to store values. It provides high performance, high availability and easy scalability. MongoDB works on concept of collection and document. We are storing and extracting the data by using PyMongo. We can build the corpus according to the domain for which the interview is being conducted, and that corpus can be stored and extracted by using PyMongo library in MongoDB database. In the same way, we will store and extract interview questions and applicant answers. Once the data is collected, we need to clean the data. We will use different modules of Python to remove unwanted spaces, special characters from corpus, questions, and applicant answers. Model complexity often refers to the number of features or terms included in a given model. Here it can be defined as how we tokenize the corpus and do different types of embeddings like token embedding, interval segmentation, and positional embedding. The next step is to build the model and clean data. For model building, we are using Roboter large pre-trained model for answering Evaluator question and sentence word pre-trained model for word embedding of model answer and applicant answer. And we use quotient similarity for checking similarity score between Evaluator question and applicant answer. Roboter large pre-trained model has 12 transformer layers, 768 hidden layers, 12 multi-head attentions, and 340 million parameters. Importantly, Roboter uses 160 GB of text for pre-training, includes 16 GB of book corpus and English Wikipedia used in Word. The additional data includes Common Crawl news dataset, web text corpus, and stories from Common Crawl. Roboter is just a bot model with dynamic masking and without next sentence prediction. Here we can see the sample output of the model. For this model, we have given that any applicant who scored above 40% will clear the interview. In this case, the applicant has scored 76%, hence he cleared the interview. Here we are evaluating the model performance by comparing Roboter large pre-trained model with all other pre-trained models. On the Glue benchmark NLP task, the model achieves a score of 88.5 on the public leaderboard and achieves the state-of-art score on multi-natural language inference, question NLI, semantic textual similarity benchmark, and recognizing textual entailments at the time of release. As a result, Roboter outperformed all bot models on Glue benchmark results. Here we can see the performance table. Next is the deployment part where we used Flask and PyWebIO. Flask is a web framework, provides tools and libraries to build a web application. Similarly, PyWebIO is a Python library that allows us to build web applications and can easily be integrated to the existing web services such as Flask or Django. Here we can see the web page that displays the applicant score along with the message, "Congratulations, you have cleared the interview." In conclusion, Roboter is undoubtedly a breakthrough in use of machine learning and can be used for a wide range of practical applications and downstream tasks. Here we use Roboter and sentence BERT model to find the performance of an applicant in an interview. This can really help the companies to find the best suited candidate for a given job role with reduced time and manpower, which can indirectly help in the growth of company. It would be helpful for online universities, schools, and college level exams. During this COVID-19 pandemic, most of the educational institutes conduct examinations online. Our interview performance estimator software can assign scores to subjective questions based on answer length, keyword matching, question similarity, and contextual similarity against model answer provided by the model and student answer. Here are some suggestions for the future development. Phone interviews can be repetitive, one-dimensional, and don't give enough insights into the candidates. Since they are often used at the first stage of the recruitment process, recruiters usually find them time-consuming and challenging to coordinate. Candidates can answer text questions and have the flexibility to conduct their interview on any device and at a time that suits them best. I think so in the future this can become the first stage of the recruitment process. And here are some references. Finally, thanks for the team and university for providing this opportunity.